So this is just going to be a quick demonstration of how SearchMart works. Um, Firstly, the user is greeted with this home page where they can enter their search term and press the search button or just press enter. And this is the front end. It connects to our server on the back end, which runs our models, which actually returns the results. So as a quick example, let's say the user searches up Apple. Now the server will take a couple of seconds to process the user's input, and then it'll give back 10 nearest related responses. So as you can see, we've got the Apple iPad, iPad mini, refurbished Apple, and there's a lot of Apple products, as well as some like pink dresser, or the Mainstays classic 4-jar dresser walnut. And the reason we think some furniture items actually come on to the screen is because maybe they used descriptions at the end that were related to other foods, so it took a different context of the word apple. As another example, let's do something like chocolate. Now, what we'd expect to see is a lot of results related to chocolate, and indeed we do get a lot which have the word chocolate in it. But in addition to that, like the first term indicates, a lot of the results are also going to be related to like breakfast foods or cereals and things like that. So as you can see, the second most relatable response doesn't even have the word chocolate in it, but it's still predicted to be one of the most relevant responses. Then there's some things like it associates the word cocoa with chocolate, and cocoa again, and Snickers chocolate low-fat milk. So a lot of these results are to be expected. As a third entry, we'll do something with multiple search terms. So let's say like white tabletop. Now, our database was built to handle multiple search terms, so once the user enters all three search terms, it'll just handle it as normal and collate them together. Now, for the responses, we get the first two results just immediately I noticed contain the keyword white, which is the same as was in our search query. So an Apple HomePod might sit on top of your tabletop. That's probably why it came first. Second was the Apple iPad smart cover, which I guess relates to the first result. Then we have a white ceramic table lamp, a snack table, a chairside table, and the color black's related to white because they're used a lot near each other. So that's sort of some semantic analysis in play there. We've also got a bookcase, some beds, black and white, and then also some wall mounts. So that's just a quick demonstration of how SearchMart works. Hope you enjoyed it, and I'll see you around.
The hardest part for us, at least, was gathering the data set. Originally, we were just going to go to a starting link and find all the URLs on that page and then go to all of those and keep repeating. But after a while, we realized that we weren't getting enough URLs to stay afloat. But when we went to Walmart.com, we saw a bunch of URLs next to every product. That's when we realized that a lot of the URLs that are present on Walmart generate with JavaScript after the fact, so we had to use a JavaScript-enabled crawler. The problem with this though was visiting a single URL took about 5 seconds, and that meant that there was no way we were going to get all 20,000 in time. So what we realized was instead of grabbing the title, the rating, and the categories that we were initially going to get, all we had to do now was simply grab the URL, grab the name from the URL, and we also had the department based on where the crawler started, and we could then crawl that one link and get it multiple more. So using this technique, we were able to crawl 21,000 pages in 13 departments.
In formatting the data, we wanted to make sure that the product and the link were tied together in preparation for link analysis. We also wanted to process the data so that it would be easier to manipulate and not in its raw state from when we scraped the web. In order to do this, we separated the data into two files, one which simply contained the products and one which contained the products associated with the links as well as the categories which they came from.
So one of the challenges when building our search engine was deciding semantic relations between different words. For example, let's say I typed in the word dog. and the dog is an animal, so I would expect other search results such as animal products, maybe something for a cat, maybe something for a bird. But to a computer, dog, cat, and bird have nothing in common. So we realized that we wanted something to measure the distance between words, but not the Levenstein distance. So we decided that we would take a bunch of data, for example, the English corpus, and we were going to build a sort of table to tell us the distance between any two given words. So initially what we did was we took a big data set, the English corpus, and we went through all the files in there, and we took the top 1,000 most common words in the English language, and using that we built a set where each key value pair was 2 words, and the output would be how close they are. And the way we were going to calculate this was we looked at a word in a text and we saw how far away on average was that other word. The problem with this, however, was we realized that there wasn't enough time in this day or this week to calculate that because of how many words there were and how much data we had. So instead, we switched to another library, Word2Vec. Word2Vec basically does what we're doing, but all you do is you give it a bunch of text and it'll create this set for you where it'll map relations between the words and their sentiment related to each other. So we use that to help us with our search algorithm.
In clustering the data, one of the difficulties was deciding how many categories to cluster the data into. Now, Walmart suggested 13 categories because we got our products from 13 different categories, but we decided to pare that down to 9 categories since we thought there would be less overlap and there would just be more logical divisions. Now, we used about 20,000 iterations with 15 different starting points for the centroids in order to use our classification of the data, and we ended up creating 2 models, one being a clustering model and the other one being the vectorizing model.
After all our processing, this is how our algorithm basically works. You give it a query, which is a word or multiple words, and the algorithm takes these and puts it into a clustering algorithm to figure out which cluster of words is closest to the ones you searched. Now the algorithm takes these words, the ones